So next we are going to discuss about quadrants. In a Cartesian coordinate, we have four quadrants. This is our first quadrant, and this is our second quadrant, and this is our third quadrant, and this will be our fourth quadrant. And you can see that it is our positive axis, positive x-axis, and this is our origin, and this is our negative y-axis, and here lies our negative x-axis, and here in the upward side will be our positive y-axis. So you can say that here our positive value of abscissa and ordinate will lie in this first quadrant, and in the second quadrant we will have negative value of abscissa and the positive value of ordinate. And in the third quadrant we will have both abscissa and ordinate negative values. And in the fourth quadrant we will have positive abscissa, that is x coordinate, and the negative y coordinate, that is our ordinate. Now I'm going to introduce a new property that is also called as increment. Let me erase these so that I can draw another figure over here. Increment. So what is an increment? That I am going to draw a line over here, and this will be our vertical line, and this will be our horizontal line. That is a bit unorganized. So suppose I am going to take two order pairs, and you may say two coordinate pair. This will be our y1 and x1, and here will be our x2 and y2. So how can we say that this is an increment and this is an decrement? So increment means delta x is equal to x2 minus x1. You can see that it is our x2 and here lies our x1. So this will be our x2 and this will be our x1. By subtracting x2 minus x1, you will get an increment, that is delta x. You can also say that you can find out the value of how much a man run from this point to that point. Let me draw a man over here. He runs from x2 to x1 to this point. Okay, this is our increment over x-axis. So what if I say that how much is the rise? What if this man rise on a mountain? Suppose this is our mountain. Then you have to find out the y increment. So this will be our y increment. And here lies our x2 and here lies our y1. And in this form you can say that y2 minus y1 will give our delta y, that is our rise. And man moves upward from y2 to y1, and that is an increment over y-axis. So by using the run and rise values, that is our run value and that is our rise value, we can find out the slope. What is a slope? By concluding the ratio of rise and run, we can get a value that is slope. And slope is that tells us the direction of movement and the steepness of that object. Either it is positive or negative, we will get the idea that if it is positive slope, then the direction will be upwards. And if it is a negative slope, that means the ratio of rise and run is negative, then we can say that the slope is in downward direction. So you can also write the value of slope in this form. Slope is, suppose we are giving it as a pipette m, letter m, and the rise of us is y2 minus y1, that is in our vertical direction, and the run is obviously on horizontal direction, horizontal line, that is x2 minus x1. In this way you can find out the slope. I am also give it as a sign so that you can understand it more clearly. So now I am going to erase this all to make you understand of this figure that I am using to make the concept of slope more understandable to you guys. I'm taking a plane let me adjust it a bit. Okay, The greater the absolute value, the more rapid the rise and fall. As I described it before that if it is in positive value, m is in positive value, and if it has a greater value and it is also positive, we can say that the rise will be rapid. And if it is in negative value, then we can say that there is more rapid in the falling direction. So now we are going to discuss this figure. First one, positive slope. It is a positive slope because it is moving upward and it is also increasing. And you can see that direction is downward, then it is a negative slope, and the value of slope, that is m, will also be decreasing. And if we have an horizontal line, then that slope will be 0 and there will not be any rise and run in it. Then that is only a horizontal line. And if we have a vertical line, we can say that it is an undefined slope and that will be a vertical line. Suppose I'm going to show you how is the zero slope in the horizontal line. So it is our horizontal line. This is our plane, Cartesian coordinate, and y2 minus y1 and x2 minus x1. As you can see that here you will get an x2, but it is in a continuous state, and from here we will have a x1. We can put the values of x2 and x1, but what about the value of y? Delta y. There isn't any change in y direction in the y-axis because it is a horizontal line. We didn't get any value of y, and it is also moving from both sides. So there is no change in delta y. You guys already know this delta means change, and there isn't any change in value of y. So we can say that delta y is equal to 0 and the slope will also be 0. And what if I say that if I am going to represent the vertical line over here, and it is also moving from both sides. So it's in a ray form. So again I'm going to, here will be our y2, but we didn't get any exact value of it, y2, because it is continuously changing its value, and here will be our y1, and x lies over here, but as I said before that delta x will be 0 because there isn't any change in the value of x. So our delta x, that is x2 minus x1, is equal to 0. So if we put 0 over here, we can get an undefined value. So in this way you will also get the idea of vertical line. Example of slopes of force steepness. In slope we get two properties: direction of a moving object and the steepness of that object. And in the first figure we know that slope is 0.1. The greater the value of absolute value, the more rapid the rise and fall. And here we have 0.1 slope, and it is not that much steep, and it is a bit more steeper, that is going to be, suppose, what is meant by steep? It is a mountain, and we can check its steepness over here, from here. And suppose if I say that it is also a mountain, but it is a bit very less steeper than this mountain. So 0.1 slope, and then 1 slope, then 2, value of slope is 2, and then 4. The greater the absolute value, the more rapid the rise and fall. And in this figure, we say that it is a very steep object or moving towards upward end. Maybe it may be moves towards a downward direction, but it is a bit higher, steeper value than the figure number 1.